All right, we're doing one more lesson here on analyzing these graphs and making sure that you understand the concept of function notation and analyzing different parts of the graph based on that function notation. So the start thinking part here gives two different graphs or two different curves that you can see on the graph. Both are functions. The reason they're functions is there is no input that has more than one output for each one of those curves. And it passes the vertical line test. This is talking about the population of Baltimore and Cleveland in the 20th century. You have B of t being the population of Baltimore and C of t being the population of Cleveland. The first part says estimate B of 100 and or 1,930 or 1930. So what is that talking about? That is talking about what is the population of Baltimore going to be in 1930. If you go to your graph for the input of 1930 and go up, you will see it is about 800,000. So it is 800,000, and the explanation is that in 1930, the population would be 800,000. The next one, we are trying to figure out which one of these statements is correct. The first one is basically saying in the year 2000 is it's saying that the population of Baltimore is going to be over Cleveland, and the other one says the population in 2000 of Baltimore is going to be under that of Cleveland in 2000. And the one that was correct is if you look at the graph for an input of 2000, it is Baltimore is going to have a greater output of a population. For the next one, it is asking in 1900, are the populations going to be the same, or is Baltimore going to be a higher population than Cleveland? And it is, when you take a look at this, you can see that Baltimore is going to have a higher population than Cleveland. The next part says, were the two cities' populations ever the same? If so, when? You can see that they crossed paths at about 1943. So you could say B of 1943 equals C of 1943 if you wanted to use function notation. And then also in 1910s, you could say B of 1910 equals C of 1910. The other thing that I worked on with the students was we were remembering and just practicing the concept of average rate of change. So I asked them, what was the average rate of change for Cleveland between 1900 and 2010? Now you can see it started at about 400,000 and ended at about 400,000. So it had a overall change of dependent, which is population of 0 people over 110 years. So even though it goes up and down and flat and all that, if we look at the average rate of change for that 110 years, it is going to be an average rate of change of 0. When you're looking at Baltimore, on the other hand, it would have a positive average rate of change. All right, let's keep on going here. The next one was we were looking at this application that was talking about landline use versus cell phone use. When I was a kid, nobody had cell phones, and every single household had a hardwired landline. And then slowly over time, what ended up happening was people saw that they could just use their cell phone all the time, and they didn't really need to have a landline. So the landlines went down, the home phones went down, and the use of cell phones went up. So this first part is saying, what is H of 2006 and C of 2006? So when I looked at this, I had to guess a little bit, but in 2006, for me, it seemed like home phone use was about 87% and cell phone was about 13%. And let's see, what was the approximate solution to C of t equals 20? That's basically asking, when did cell phone use hit about 20%? You could look at the output where 20% is and cruise over, and you see that's about 2008. So we could technically write C of 2008 equals 20 if you wanted to use function notation. Now the next one says determine if the following are true or false. They have C of 2011 equals H of 2011, which is basically saying the percentage of cell phone users and home phone users would be the same in 2011. That is incorrect. It's actually in 2015 that they become about the same. So you could say C of 2015 equals H of 2015, which equals about 50% for each. The next one was looking at average rates of change, and it was wondering if the increase for cell phones was equal to the decrease of home. So I said that was about 92% for home in 2004 and about 8% when you were taking a look at a cell phone. So I looked at the change. There was a 42% decrease for home and about a 42% increase for cell phone over those 11 years, and you can see that they are the same rate. One is just negative and one is positive. So it says, between these years, did the percentage of homes and landlines decrease at the same rate at which the percentage of cell phone use home increase? I said yes, and I showed the reason why. Next on here, you are given 3 different graphs. They're talking about these different sitcoms or TV shows that had 10 episodes, and they tell you a little story about each one of the situations, and you're supposed to match the graph with it. There's going to be one situation that had no graph, and then we had to make the graph for it. One thing that messed me up and I had to start over was I was looking at show A, and it looked like it was just taken off. And what I didn't realize was on the left, when you're looking at the dependent variable, which is going to be the audience in millions, that actually only went from 0 to 2, whereas the other one went from 0 to 10 and 0 to 6 million on the other one. So the one that was a dead giveaway is one of them is talking about, it says, the show has a good core audience. They had a guest star in the 5th episode, which brought in some viewers, but then most of them stopped watching after. I could see that one of those graphs had that point that was popping up at 5 episodes, and that was C. So that was that. The next one says the show is one of the most popular shows, and its audience keeps increasing. I originally thought that was A, but then I saw that it was going from 0 to 2, so it wasn't super popular at first. The next one, this show has a small audience, but it is improving. That one was truly A. You can see it starts out low, but it's increasing. And then the last one says the show started out huge, even though it looks like it crashed. It still has more viewers than the other. That would be B. You could see that it was super high at first, came down, but still, even at the end, we're still at about 4 million. And if you look at everything in show A, everything is below 2 million. So even though the graph looks bigger or better, it's the fact that it was going from 0 to 2 million versus 0 to 10 million in show B. Then they wanted us to check the values of A of 7, B of 7, and C of 7 to figure out which one was going to be the greatest. When I looked at this for each one of them, I had to approximate a little bit, but when I approximated, it looked like 1.75, 3.7, and 3. So the biggest would be for B. And then I went over and drew the graph that I came up with for the one that was missing, which was the explanation for B. Now let's take a look at this last one. This last one was asking for you to look for the outputs to see if f of 2 or g of 2 would be bigger, if f of 4 or g of 4 would be bigger, and so on. And if you look at this, at an input of 2, g is going to have bigger outputs. It's higher, so that one would be bigger. For the next one, for f of 4 and g of 4, they're actually going to have the same output, and the output is 7. So they are going to be equal. Then at 6, the f of 6 is going to be giving a bigger output. If you look at 6, f is going to be higher, bigger output, and the same thing for 8. F is going to be higher, so it's going to be putting out a bigger output. It says, is there a value of x such that f of x equals g of x, meaning the outputs would be the same? Explain your reasoning. So yes, there are 2 values at both at 4 and at 9. Both of them would be about the same. So f of 4 equals g of 4 equals about 7 for the output. And then f of 9, g of 9 are equal, and that is going to be about 5.8. And the last one, identify at least 2 values where f is going to be less than g. So 1 and 2, for the inputs of 1 and 2, both of those are going to have smaller outputs for f than g. Now for your homework here, you guys are supposed to be looking at these functions for R and D, given the height and feet of a toy rocket and a drone t seconds after they're released. You have your graph there. Here's the graph for R and D. Write a statement for each. It says at 3 seconds, the toy rocket is going to be higher. So I said R of 3 is greater than D of 3. The output is going to be bigger for R than D. The next one says at the start, the toy rocket is 20 feet above the drone. I said the output for the rocket minus the output for the drone is a difference of 25 feet. And to be clear, I'm saying that the input of 0 for each one of those would be the initial. So R of 0 minus D of 0 equals 25. Now, I got the second one wrong at first, because when they say that you're going from, well, there's 2 issues. Number one, the graph is funky because an increment, it says an increment is 2 months. and then they go to an increment meaning 1 month. So that's weird on the bottom. The other thing is it says it goes from the beginning of January to mid-March, which I thought was 3.5, but that doesn't make sense. All of January would bring you from 0 to 1. All of February would be from 1 to 2. And then the middle of March would be 2.5. So I actually had to go back and rework this problem. So I have the new one. If you look at the temperature at 2.5, that's about 42. 42 minus the original 35 divided by the 2.5 months gets you 2.8 degrees per month. And the other one looks like the new was at about 35 at 2.5 months. And I took away the original, which was 25, and I divided by 2.5 months, and that got me 4 degrees per month. So it still is going to be Minneapolis has the temperature increasing faster, bigger rate of change. The next one is just asking for what is f of -2. So you were supposed to substitute in -2 for the input. And when you substitute -2, you end up getting 9 times 5, which is 45. So f of -2 equals 45. The next one is asking what is the value of x that would make this true. So on this one, I distributed in the 5 to get 5x plus 55 equals 90. I subtracted away 55, which left me with 35. And when I divided by 5, I got 7. So that should work. 18 times 5, let me check in the calculator, 18 times 5 is 90. So that would be the correct value of x. Now, the other ones, these messed me up a little bit because I'm so used to the leftmost part being 0, but 0 is actually in the middle for your x's or your horizontal axis. So you were supposed to be figuring out which one of these statements were true. The first one says that F has a bigger output at 0 than G does, and that is incorrect. G is bigger. The next one says there are two values of X where they are going to have the same output. That is correct. It looks at like maybe -2 point something and at 3 point something for your X's. The next one says F of -1 is less than G of -1. That is saying that F is going to have a smaller output than G at -1, which is correct. And the last one says F of -3 is going to be bigger than G of 4. So when you look at F of -3, F of -3 is going to be about F of -3 is about 9-ish, I would say 9-ish. And then G of 4, when we look at G of 4 is about 6-ish. So yes, 9 is greater than 6. Got to be careful there because they have different inputs. On this next one, they have 3 graphs, and you're supposed to be talking about the different runners and what this is telling you. It says one runner ran at a constant rate throughout the race. Who was it? You can see that racer C is that dashed line. That one would be, you see, a constant rate of change. The next one says a second runner stopped running for a while. Who was it? You could see that A stopped running. The next one says described the third racer. So what happened to racer B? It looks like that they had a faster rate of change compared to C at first. And then in about 27 seconds, they began to slow down and got behind C. And then lastly, who won the race? Who got to 400 meters fastest? And it was racer C, or runner C. Now for this last one here, they say function A gives the area in square inches of a square with side length x. You should know that area is just length times width for a rectangle or a square. So it's going to be 0 times 0 to get the area if it is a side length of 0, and 1 times 1, and 2 times 2, and 3 times 3, and so on. So I filled out the table, and you can see the values I got here, 0, 1, 4, 9, 16, 25, and 36. I graphed those because they asked for it. And then it says when you have a side length of x, what would a of x be? Well, we saw that all we kept doing was just squaring the side length. So I said a of x equals x squared. Hopefully that makes sense. Thanks for watching.